Okay, today, fifth graders, is Monday, August 26th, and we are starting again, just like fourth graders, with Eureka Math Lesson 1.1. The EM stands for Eureka Math, and 1 means Module 1, Lesson 1. Every day in your math notebooks, I want you to write this down because when you go back with your math notes, you want to know what notes were for which lesson. Does that make sense? And today what we're doing is we're learning how we can use pictures and numbers to show how adjacent place values are related. What does the word adjacent mean? What does the word adjacent mean? Yukaksh?
Next to.
Next to. So right now, Adi is adjacent to Shobit, who is adjacent to Maria, who is adjacent to Jonah. All 4 of which are not ready to take math notes because their math notebooks are closed. Baham is adjacent to Mira. Point to someone you are adjacent to. Adjacent means right next to. Okay, very good. So today we're going to look at how place values, places that are right next to each other, are related. We already know. They are 10 times bigger or 10 times smaller. Yes? But we're going to see how we use pictures and numbers to one way to represent that. Okay? Our place value chart has lots of different periods. It has your standard ones, tens, and hundreds. Do you see that? Okay. What would the red period be called? You guys see the one that's red? Taya? Thousands period. And there we'd have 1,000s, 10,000s, and 100,000s. There's a green period as well. That's the millions. We'd have 1 millions, 10 millions, and 100 millions. But in 5th grade, all you need to know is up to the millions. Then there's a black period. Do you guys see that one with the black rectangle? What is special or what's different about that period compared to all the other periods we've talked about thus far? Mira?
That is the decimal period?
It's in the decimals. It's to the right of the decimal points. That means everything over here is greater than 1. Over here, it's a decimal, which means it is less than 1. Okay? And there we have 1/10, the tenths, the hundredths, and the thousandths. It sounds a lot like tens, hundreds, and thousands. The difference is the ones over here, hundreds ends with a D. Over here, hundredths ends with a TH. Okay? Do you guys see that? So, these are all the place value positions that in 5th grade you need to know about. You need to know from the thousandths all the way up to the millions. For the thousandths, it would take 1,000 thousandths to equal 1. This is 10 times smaller than this. We know that, right? So if I took 1 apart and broke it into 10 small pieces, each of those pieces would be 1/10. Then if I took 1/10 and broke it into 10 small pieces, each of those would be 1/100th, because it would take 100 of them to equal 1. If I took 100th and I broke it up into 10 pieces, that would be 1. Because how many of these would it take to make 1? 1,000. Very good. As I move positions towards the left, does the value get bigger or smaller? Yeah, so as I move to the left, the value gets bigger. Okay, and as I move to the right, the value gets smaller. You got it. Now, my first question was, what number did I just represent on my place value chart? 1 million, because I drew a 1 in the 1 millions column. Good. Now, what happens if I take that 1 million and break it up into 10 pieces? What would I get? What would I get?
10.
I would get 10 100,000s, right? Now, what if I had 100,000 and I want to break that into 10 pieces? What would I have? 10 10,000s, yeah. So if I, so if I have one of these, I want to break it into 10 pieces, I have 10 100,000s. What if I had 1 10,000 and I want to break that into 10 pieces? What would I have?
10 1,000.
10 1,000s. What if I had 1 1,000 and I want to break that into 10 pieces? What would I have?
10 100.
10 hundreds. If I have 100 and I want to break that into 10 pieces, what would I have? 10 tens. I know, you're like, come on, Miss O. Yes, I will come on. What if I had 10 tens and I want to break that into 10 pieces? I'd have 10.
10 ones.
Okay. What if I had 10 ones and I want to break that into 10 pieces? I would have 10. 10 tenths. That's how we say that. 10 tenths. Good. What if I had 1/10 and I want to break that into into 10 pieces? I would have
10 hundredths.
10 hundredths. Good. What if I had 100th and I wanted to break that into 10 pieces? I'd have 10.
10,000.
So by doing this, we can see that when I move one place value over to the right, it gets 10 times smaller. Very good. So what we're learning here is if I go from one place value and I go adjacent one step to the right, it gets 10 times smaller. A way that we say we're getting 10 times smaller is we are dividing by 10, right? Now if I go from one place value and I go one place to the right instead, it's getting 10 times bigger. And we do that, of course, by multiplying by 10. Okay? So if we look at this example, let's look at the first one. Copy this down in your notebook. 0.4 times 10. If I have 0.4, that's 4. Yeah, that 4 is in the tenths place. Do you see that? So that's 4 tenths. Go ahead and write a 4 in your tenths column. Now, it says to multiply by 10. That means I'm going to make it 10 times bigger. How do I make a number 10 times bigger? Do I move it to the left or to the right? Left, because moving to the left makes it bigger. If I want to make it 10 times bigger, how many times do I have to move it to the left? 1. So literally copy what I'm doing. Draw the arrow and show that you are shifting it one space to the left. Now my 4 is in the what's column? The ones. So what is 10 times bigger than 4 tenths? 4. Very good, because my 4 is now in the ones column. This time we have 4. We still have the digit 4, but the 4 is in the what's place this time? Hundredths. So go ahead and draw a 4, or write a 4, in your hundredths column. Now we still want to multiply by 10. So we're still going to make it 10 times bigger by shifting it. Is it shifting it to the left or shifting it to the right? Left. And if it's going to get 10 times bigger, how many times do we have to shift to the left?
1.
So again, you're going to draw that diagonal arrow. That's a terrible arrow. You're going to draw a better diagonal arrow to show that you're shifting it 1 time to the left. And now, for our product, the answer is in the what's column? Tenths. So what is 10 times bigger than 4 hundredths? 4 tenths. And we write that, of course, by writing 0.4. We use the decimal point to show that this is the 4 is in the tenths column. Yes? Okay, for the last one, we have 4 thousandths this time. Do you see that? So that means my 4 needs to be in the thousandths. And we're still multiplying it by 10, so we're still going to shift it one space over to the left. And now my 4 is in the hundredths. So what is 10 times bigger than 4 thousandths, Gaurav? Good, 4 hundredths. And we write that by using these placeholder zeros to show that my 4 is in the hundredths column. Our first problem says 6 divided by 10. So we have to put a 6 in the what's place. In the what's place? Okay, go ahead and write a 6 in the ones place. This time we want to make it 10 times smaller. If we want to make it 10 times smaller, do we shift to the left or shift to the right? To the right. And how many times should we... One column, because we're making it 10 times smaller. So if we shift it one column to the right, now my 6 is in the what's place, everyone? Tenths. Careful, not the tens, but the tenths. In class, we're really going to enunciate the to show that is the decimal tenths. Good. And so we write that in standard form by writing 0 and then the decimal point. And then now my 6 is in the tenths place. Okay, for our second problem, we still have 6 in the what's place? Ones, good. But this time we want to divide by 100. Well, when I shift it one place to the right, it gets 10 times smaller. But if I shift it 2 places to the right, it'll get not 200 times smaller or 20 times smaller. 10 times 10, which is? 100. Good. So if I want to move it, if I want to make it 100 times smaller, I have to shift it 2 times to the right. Do you guys see that? So now my 6 will be in the what's column? Hundredths. Good. And so we can write that answer by writing 0.06. We need this 0 here to show that it's not in the tenths place, but it's in the hundredths place. Do you guys see that? Okay, we can think of it like this, 0.06. Each time we shift to the right, it's getting 10 times smaller. So 10 times smaller, 10 times smaller, 10 times smaller. That means each time you do it, it's 10 times smaller. So this time, if I want to divide by 1,000, how many times am I shifting? 3. Go ahead and show that on your place value chart. In order to divide by 1,000, we're going to divide by 10, 100, 1,000. So then our 6 ends up in the thousandths column. So my answer would be 0.006, or 6 thousandths. that make sense? Good. What happens when you shift a digit one place to the left? Allie? Gets bigger. How much bigger? 10 times bigger. Good. What happens when you shift the digit one place to the right? Sakina? It gets 10 times smaller. Very good. So if I have a problem like this, 2.43 times 10, I would model it on my place value chart. Do you agree that this is 2.43? My 2 is in the ones place, my 4 is in the tenths place, and my 3 is in the hundredths place. If I want to multiply it by 10, I have to shift each number to the right or to the left. What do you guys think? To the left. How many times? 1. So I would show each number is shifting to the left by 1. Okay. Does the decimal point ever move? No. So what is 10 times bigger than 2 and 43 hundredths, or 2.43? 24 and 3 tenths. Good. Okay. Now,